So, unfortunately, even things that are going to give us really good power and not burn a bunch of fossil fuels aren't without the risks. So, let's take a look at some of these risks. So, hopefully, you all have heard about Chernobyl before. I have to admit, I'm starting to get to the point in my career where I'll mention something that was major that happened in my lifetime, and I have started to get some blank stares from students. So if you've never heard of it, it's okay. But if you have, even better, you've got a little bit of context. So basically, what happened is back in 1986, one of the reactors at Chernobyl blew up. Tons of radioactive material ended up getting spread into the surrounding area, and so it created this like exclusion zone for a really long time. So it wasn't even just ground zero, but a whole radius because the winds spread everything way far out. So there's a lot of people that were impacted right away. So there were some pretty, immediate deaths. But as I was saying, like even the people that were exposed to less radiation than causes immediate death still had problems later. Now, one of the problems is the material that was used for the control rods. So those control rods are supposed to stop chain reactions and prevent meltdowns or things from blowing up. What happened here was the control rods were not made out of the same material that we use here in the US. And so they caught on fire. So didn't do a lot to actually stop the chain reaction. So that was a problem there. All right. So what ended up happening was basically they were performing a safety test and there was a huge power surge and it ripped open the core. It destroyed the cooling pipes, huge steam explosion. So the concrete covering was blown away and a whole bunch of stuff was emitted because there's a lot of different things, as we've seen, that these reactor fuel rods are made out of. It's not just uranium-235. There's a lot of other stuff there. And so there's a lot of other radioactive byproducts as well. And so shot up and out. And so so again, here's where I, was mentioning, cancer. So iodine 131, it can cause thyroid cancer. And so if you end up ingesting a bunch of that iodine, which is one of the things that was emitted here, it can cause cancer. Okay. And so lots of people died initially. Untold number, 150,000 people had to be evacuated. Large part of Europe was under a radioactive cloud. You can see the red circle on here. That was the original exclusion zone from where the power plant explosion happened. Initially, it was this nice circle, but as they tracked everything and like the way the winds blew and everything, it ended up being a little bit more irregular of a pattern. They found radioactive material super far away, and here's the interesting thing. This statistic here on this, the fourth bullet point. Future cancers, estimation anywhere from 7,500 to 1 million. And so that's one of the things that scares a lot of people. Okay, is it's unknown. We don't have all the answers for exactly how much radioactive material everybody was exposed to and just how much of an impact this has. And the unknown scares a lot of people, which is why these accidents and this unknown causes a lot of people to be really worried about nuclear power, when in reality, there's a lot more nuclear reactors giving power out there than you realize that haven't had any problems at all. Plus, this accident happened in 1986. It's 2024. It's been almost 40 years. And our technology and our understanding of how to build nuclear reactors is way, way, way better than it used to. And that's part of why some older reactors are starting to be decommissioned now, is we have better ways of doing things. And again, yeah, large amount of uncertainty and fear. There were a lot of political consequences. They tried to cover it up. People tried to downplay health and impacts. And so a lot of public opposition spread up because the government didn't do a good job of actually informing people of what happened and what they understood to be the impact or effect. And what's interesting is we just kind of went through something like this with COVID. We didn't cover any, well, I don't know. I don't want to get like super political or anything. This is a science class, not a political science class. But, that's the thing is like stuff like this has kind of eroded some of the trust in the relationship between scientists and the government. And a lot of people don't understand the way science works. We don't have all the answers right away. Science is an iterative process. When something new happens, like a giant explosion, a meltdown, the best thing is to give the information that's out there and not to cover it up. One of the dangers of that, though, is that when you don't understand science, the information you have today might change from the information you have tomorrow as more tests are done and you have a different sample size and you start to get more answers. We don't know everything from day one. We have to wait for things to happen and see how things occur. And that's what was happening like with COVID, is that as a scientific process in real time, we were finding new things out every day. That's why it seemed to be that, from one day to the next, the information totally changed because we were trying to figure this out. And instead of covering up, more information was given. And so you get to see kind of how that played out in real time. All right, another disaster. This one was more recent, Fukushima. So there was an earthquake and a tsunami that happened in the Fukushima Daiichi region in Japan that damaged the Fukushima reactor. And so they lost the power for cooling water. Overheating happened. We ended up with a reaction that generated hydrogen gas. They didn't want another Chernobyl to happen. And so they vented hydrogen, released some of that iodine into the countryside, and we still had explosions. Like the venting didn't solve the whole thing, and so radioisotopes were emitted. What was interesting is if you remember when this happened, every day it was one of those things, or daily we got new information. They were tracking the radioisotopes as they were emitted, and kind of following along with where did they go, what concentration were they in, how far out. And so they, started to see them show up further and further away, showing how far these things can travel. So that was a really interesting one to watch in real time, but they did avert a full-on Chernobyl. There were people that ended up having to manually do some of this stuff, and at great danger to themselves because the power was knocked out. But they didn't want that to happen, and so they ended up risking themselves to manually take care of this to prevent that from happening again. So, again, more nuclear plants than you realize. 20% of commercial power is produced from about 100 of these nuclear plants. We have 62 nuclear sites in 31 different states here. All right, and so what's interesting though is we've continued to increase it steadily. But now we've seen a little bit of a drop. There were more nuclear reactors in 1990. And again, part of the power increase, we have improved reactor efficiencies. We've upgraded reactor components, but some of the loss of the number of plants has to do with, again, as we've gained better technology or as we've started to use up some of our fuel rods, we've started to decommission some of our nuclear plants. And then it's a question of, can we retrofit to bring them up to current standards? Do we need to tear them down? And if we do, what do we do with everything that's been exposed to radioactivity? Or do we just kind of have to let them sit as a monument to what they once were? There's a lot of these questions that have to be answered about what do we do with these decommissioned sites. So we've started expanding nuclear power in developed countries because we really do need to get away from fossil fuels. Again, they're finite. We don't have them forever and ever. Like, they're not going to sustain humanity until the end of humanity. We really need to get away from them. And they're damaging our environment, as we've seen when we looked at climate change. Like, fossil fuels are not good. We definitely need other energy sources. So There are regulations that they have to take care of. They need portable safety equipment. They need to be able to burn off hydrogen that's generated in one of these if there's an accident. They need better venting systems so that they can contain all this stuff. And they need to look at water levels in the spent fuel pool. So there's a lot of regulations. So they're not just these, renegade nuclear plants that just have radioactivity spewing everywhere. There's a lot of rules and regulations. And again, as we've developed more of these, we've gotten to the point where some of our older reactors are getting to an aged issue where can we retrofit them to uphold the new regulations, or do we just kind of have to let them go and then build a new one? That's not a question I have an answer to. There's a lot of different factors that go into that. So nuclear power is a good option as long as we continue to have all these checks and balances and keep it as safe as possible.